Hello, a very warm welcome to my class. In this class, we are going to discuss exercise 1.2 from the chapter number systems. And if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications also. If you have any doubts, you can ask that as comments. Okay, so let us start now. And the first question is, state whether the following statements are true or false. And in that first subpart of the question is, every irrational number is a real number. So, is this statement true or false? Every irrational number is a real number. So, for that, I'll explain you in detail. The real number line consists of natural numbers. What are natural numbers? Natural numbers. So, what are natural numbers? 1, 2, 3, 4, 5, etc. are called natural numbers. So, it will go on like this. Then, we have 0. If you include 0 in this, we have whole numbers. Okay. Now, these are integers. 1, 2, 3, 4, 5, etc. are integers. And if we add negative numbers, negative 1, these are positive integers. And if we add negative 1, negative 2, negative 3, that is negative integers, then this is called integers. So, we have integers also, positive and negative integers. And if we, this 1 by 2, 3 by 2 and all are fractions. So these are also included. And any number which can be expressed as P by Q, where Q is P and Q are integers and Q not equal to 0 are called rational numbers. So these are rational numbers. 1 by 2, 3 by 2, etc. are rational numbers. And these are also rational numbers. We can express this as 1 by 1 and 2 as 4 by 2 and so on, right? So these are rational numbers. So rational numbers are also included in this real numbers. And we have one more, that is irrational numbers. What are irrational numbers? Irrational numbers are the numbers which cannot be expressed as P by Q. And for some examples, we have root 2, root 3, root 5, root 6, root 7, root 8, etc. So these are irrational numbers. And the question is, every irrational number is a real number. And here we have irrational numbers on the real number line. So, irrational numbers are also in this real numbers, which means irrational numbers are included in the real numbers. So, every irrational number is a real number. So, all these are real numbers. We have natural numbers, whole numbers, integers, that is negative integers as well as positive integers. In whole numbers we have 0. Then rational numbers means 0 is also a rational number. Then we can express 1 by 2, 3 by 2, etc. So these are rational numbers, and irrational numbers are the numbers which cannot be expressed as P by Q. So root 2, root 3, root 4. Root 4 is not an irrational number because root 4 can be expressed as 2. So root 4 is 2. So it is not an irrational number because 2 can be expressed as 2 by 1. So all these are real numbers. All these are included in the real numbers. Okay. So irrational number is a real number. Every irrational number is a real number. Okay. Next one, every point on the number line is of the form root m, where m is a natural number. Every point on the number line is of the form root m, where m is a natural number. So let us consider number line 0, 1, 2, 3, etc. And -1, -2, -3, etc. And the question is, every point on the number line is of the form root m, where m is natural number. Here, this is root 1. This one is root 1 and 2 is root of 4 and 3 is root of 9. But is minus 1 root of 1? That is, it is only natural number. So, these negative numbers are not the square root of natural numbers, which means this statement is false. So, this is not true. The statement that every point on the number line is of the form root m, where m is a natural number, is false, because negative numbers cannot be expressed as root m. Positive numbers can be expressed as root m, but negative numbers cannot be expressed as root m. And on the number line, there will be negative numbers as well as positive numbers. Okay. Next one is every real number is an irrational number. Is that statement true? No. Because every real numbers consist of negative numbers, then 0, then positive numbers, rational numbers like 1 by 2, 1 by 3, etc. Then irrational numbers root 2, root 3, root 5, etc. So, is every real number, these are all real numbers, but they are not irrational numbers, right? So, this statement is false. Every real number is not an irrational number, which means the statement that every real number is an irrational number is false. Now, second question is, are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. So, are the square roots of all positive integers irrational? No, right? Because square root of 4 is 2, which is rational. 2 can be expressed as 2 by 1. So, this is rational. But square root of 2, it is irrational. And square root of 9, what is square root of 9? It is 3, which is rational. So, are the square root of all positive integers irrational? No, they are not irrational. Some are rational. That is, if it is a perfect square root of perfect square numbers like root 4, root 9, root 16 is 4, then root 25 is 5 and root 36 is 6 and so on. So, these are not irrational numbers. Okay, understood? Next one is show that root 5 can be represented on the number line. So, we can draw it 0, 1, 2, 3. And negative numbers are also there, negative integers. Now, what we have to do is first draw root 2 on the number line. To draw root 2 on the number line, we have to take this 0 to 1. Name this as O, this as A, and then draw a perpendicular. Draw a perpendicular from this A, which is 1 unit. Okay, and this is also 1 unit. Right? 0 to 1 means this is 1 unit. And draw A to B. A to B. This is point B. Now join this OB. What is the length of OB? It will be by applying Pythagoras theorem. This is hypotenuse. So, OB is equal to root of OA square plus AB square. Right? So, that is equal to root of 1 square plus 1 square, which is equal to root of 1 plus 1, and that is equal to root 2. So, this is root 2. This length is root 2 units. Now, if place the tip of compass on O and take this length OB on the compass and draw an arc like this. So, this length is root 2. This length is root 2 because this length is root 2 and we have taken this on the compass and drew an arc. So, this length will be root 2, which means this point is root 2. So, we have drawn root 2 on the number line. Now, what we have to do is draw root 3 on the number line. That is, locate root 3 on the number line. How will we locate root 3 on the number line? Just draw a perpendicular from this B, which is 1 unit, and then join this. Let this point be C, and we can join this. So what will be the length of OC? OC is equal to root of OB square plus BC square, which is equal to root of root 2 square plus 1 square, which is equal to root of 2 plus 1, and that is equal to root 3. So this length is root 3. Now same thing, we can keep the tip of the compass on O and draw an arc. Take this length OC and draw an arc. So this point will be root 3. Now what is root 4? It is 2. So this is root 4. And for drawing root 4, we can draw like this. So take 1 unit and draw a perpendicular from here and draw an arc like this, and this will be root 4, and if you draw this arc, this will be root 4, which is 2. Now we can draw root 5, that is we have to draw root 5 in the question, that is locate root 5. So we can draw a perpendicular from here, which is 1 unit, then join this, join this. So let us name this as D and let us name this as E. So join this OE, and this will be root 5, because root of root 4 square plus 1 square is root 4 plus 1, which is root 5. Now place the tip on O of the compass on O. Take this OE and draw an arc. So this will be root 5. This point will be root 5. This is how we locate irrational numbers like root 2, root 3, root 4, root 5. Root 4 is not an irrational number. It is a rational number because root 4 is 2, which can be expressed as 2 by 1. So this is how we locate irrational numbers on the number line. Okay, so we have located root 5 also on the number line, and the question is show how root 5 can be represented on the number line. This is how we can locate root 5 on the number line. Understood? And with this we have completed this exercise 1.2 from the chapter number systems, and I'll be continuing with exercise 1.3 in the next video. And if you have not subscribed to my channel, please subscribe and do like the video if you like my class, and share it with your friends. Do not forget to click the bell icon to get notifications also. If you have any doubts, you can ask that as comments. Okay, so thank you and bye.